Welcome to the Enterprise Storage Masterclass. Why do data centers use massive storage arrays instead of single hard drives? A single enterprise SSD is fast, but its single controller represents a hard bottleneck for performance. By combining multiple SSDs into a storage array, the controller writes data across all drives simultaneously, massively multiplying your input/output operations per second, or IOPS. Storage networks come in three main topologies. Direct Attached Storage, or DAS, is plugged directly into a single server. Network Attached Storage, or NAS, shares file-level data over standard Ethernet switches. But for extreme performance, enterprises use a SAN, a storage area network. A SAN speaks block-level protocols, making the network storage feel like a local physical drive to the server. A SAN is a completely separate, high-speed network. Servers connect using specialized host bus adapters, sending block-level CZ commands over optical fiber channel cables. This traffic flows through a dedicated SAN fabric switch, routing requests to massive storage arrays equipped with highly available, dual storage processors. However, connecting everything together creates a security risk. By default, every server can see every disk. To secure the fabric, administrators configure zoning on the SAN switch. Notice how the red and blue zones communicate securely. But if the blue server attempts to access the red storage array, the switch uses hard zoning to physically block and drop the unauthorized connection. Finally, architects must divide the array into logical slices, called LUNs, while carefully managing performance. By assigning dedicated physical drives to the SQL database on LUN A, its massive 50,000 IOPS A workload will never slow down the file server on LUN B. Watch what happens during a critical drive failure. LUN A's dedicated hot spare activates instantly to rebuild the database array. Because they use physically isolated drives, LUN B's performance remains completely unaffected, guaranteeing total business continuity.